Configuration management, that's the theme for this week. Hello, you're watching the development vlog for Shokken, a restaurant waitlist management tool that is currently available on Google Play Store and iOS App Store. This is Bill from Shokken, and this is week 79 of development. Current status, as I just mentioned, the app is generally available for download and use in the United States on both Android and iOS. Please go ahead and do that. The link is in the description. The theme for this week is configuration management. And what is that? Why do we need that? And why did I wait so long to do this? That'll be a very interesting discussion. Before we go there, one of the most important things to understand is when you're building an iOS app, an Android app, like what I'm doing right now with Shokken, it is very different from building a web app. Now, there's a lot of big differences between those two different platforms. You got language differences, framework differences, and all of those. I'm not talking about any of this. I'm talking about the simple concept that a web app is not centrally controlled by anybody. When you write a web app, and you you build from your source code into a publishable web app. Anybody with any browser that's not controlled by anybody, you can use Edge, you can use Safari, Chrome, Brave, all of that. Anybody with a browser can then visit your website, fetch the information from your web app, and then just display on the computer. Right? It doesn't have to go through any third party other than, of course, the traffic and stuff. But like the information coming from your site can reach anybody without any restrictions in general. This is not true with apps, in particular Android and iOS apps. For one, they're controlled by their respective platforms, iOS by Apple and Android by Google. Just a side note, it used to be the case that only iOS apps were heavily locked down. It's since the beginning, it's always been a case where, if you have an iOS device, especially after they started using I believe they called the M1 security chip, security enclave, where the phones literally become uncrackable or really not economic to crack. If you use an iOS device, any apps that show up on your device would have to be sanctioned and approved by Apple. If you were to just create an app for an iOS device, you can't just distribute it to people, right? You have to go through their platform. And this didn't used to be the case for Android. On an Android, one of the biggest selling points, one of the reasons why people love Android so much was that despite being a platform being controlled and, I guess, published by Google, you still had a lot of freedom in terms of what you want to run on your Android device. You can just get an unsigned APK, the app, or whatever file you've managed to find anywhere, put it on your device, and it would run. Very recently, Google has very publicly made the decision to make that not a thing anymore. Received a lot of criticisms, and like any unpopular things that big corporations or governments would like to do, they sort of backed off a little bit, reneged on their decision, and then let the thing boil down and simmer a bit, and then they reintroduced it. As far as I understand, I don't know the details, but I do know that they are sort of cinching it up such that it's not as free as it used to be. In any case, I'm not trying to make a political point in this video, but this introduces a very interesting problem, which is because they're controlled by those publishers, those parties, any changes that you make to your app is not immediately deployable or immediately seeable by the users who are using your app, right? So this creates a very interesting problem where your app is not just standalone. Your app is not just binaries or code running on people's devices. Your app also contains stuff in the backend. Your backend Supabase. For me, I use Supabase, the Supabase services in the backend. Your app on the phone talks to the backend Supabase. So the backend, Supabase backend can be deployed very similarly in terms of timeline as web apps. In other words, if you change something in your backend, we're going to talk about like highly complex setups with different load balancers and traffic controllers or orchestration layers. We're not talking about any of those. We're talking about the simple single point backend services that a lot of those simple web apps, or not web apps, web apps and mobile apps would use, right? For this, when you deploy it to Supabase, Supabase runs deployment against the environment itself, and then voila, within 5 to 10 minutes, you have a new environment with the new code and new logic. So that's it. In that way, it's very similar to web app development. Very deployment, very fast, immediate. So this creates a very interesting problem. Say you're developing a feature, and the feature that I developed very recently is adding the capability for people to generate a QR code menu. In other words, the restaurant can display a sheet that says, please scan this for the QR code for a menu. Now, I understand QR code menu is not terribly popular in the United States right now. Again, this is not the point of this video. The app already has the functionality of scanning a QR code for people to join a waitlist and browse the menu. So going from that to just allowing people to view the menu is not too big of a jump. So I decided to implement that feature for a handful of restaurants that might be interested in that feature. Imagine you're trying to implement this feature. So in the front end, you're developing, a user interface for people to put in the menu items, to select the menu to display, to generate the QR code, and to display the QR code, right? There's a whole bunch of front end that you need to design for that whole sort of a user flow to happen. At the same time, your backend should be able to comprehend the request coming from the front end. Be like, oh, please show me information for this particular menu and this particular QR code. The backend needs to be able to respond to that. So the code and stuff in the backend needs to change. And those two things need to change at the same time for this feature to become available. Okay, so that's all well and good, except what we just learned. The changes to your backend is immediate, but the changes to your front end is not immediate. So what do you do? Now, one thing, of course, is that you want to make sure that when you're designing it, the front end is, both the front end and back ends would be able to do backwards compatibility with each other. In other words, say your front-end team has finished developing the front end, they can't possibly stop the front end from not having that code, right? Because it's already developed in your branch, and then it's going to get cut at some point for deployment. However, that code needs to be able to tolerate the backend changes, right? The backend is not going to say, okay, we're going to randomly change the contract with the front end, but like for any new additions, the front end code ought not to break because the backend introduces new code. So and the same, vice versa, when the backend code changes, it can't just break the contract with the front end. So they need to be cross-compatible and backwards compatible with each other. But it still has the problem of desync, right? So like they're not going to be synced up. Sometimes your backend team might finish the feature development sooner than the front end, and sometimes the front end would win in terms of the development speed. So how do you manage that? How do you sort of sync things up for the feature to be lit? And one of the biggest problems is, if you imagine the backend development finishes first. That's okay, because the front end doesn't know anything about the back end yet, so the front end feature just won't become available. That's fine. But the problem starts kicking in if you have the front end already available, expecting the back end to support it, but the back end is not ready yet. What do you do in that situation? That's where feature flags come in, or I think they call it operator capability. I can't remember, like app capabilities, right? What it is, the concept is so straightforward, and it's like a lot of times when you think about this, you're like, why am I bothering with this? But the concept is very straightforward. In your app, you have a condition. It's just a condition. Is this flag up? If this flag is up, take this UI route. That's it. That's all what feature flag is. And more concretely, when you're building, let's say I'm building this a QR code menu. Scan the QR code, and then the user can see the menu on their mobile browser. I'm going to call this feature QR code menu. The flag QR code menu. I'm going to create that. So in the backend, I have a variable called QR code menu, and that's a Boolean, true or false. On the front end, I'm going to say we have the same QR code menu. And then when you're developing, the backend doesn't need to know the front end capability because the flag will be flipped by the front end team. So when you're developing the front end, you keep QR code menu, the flag to be false at all times, right? And until the moment you're ready for the QR code menu flag to be flipped true. Let's say you finish development of the front end, you test it and everything is okay, you confirm with the backend is ready as well, and you're ready to go. That's the moment where the QR code feature flag, sitting somewhere on the server. By the way, it's not sitting on your phone. The authoritative information is on the server so that you can change it in any time that you want on the server. You flip the QR code on the server to true, then the phone gets that piece of flag and flips it. It flips the local copy to true. The next time the user browses the app, the app would then take the route to display the QR code menu route to the user, and then the app won't crash because all the backend and everything is already available and set up, right? So that's all that the feature flag does. And I mean, there's a lot of nuances and choices in this that you can do, like what I just mentioned. It's sitting on a server. So how does the app gets it? How does the app gets it? Jesus, how does the app get it? A lot of times, especially in the implementation that I'm doing, I'm not pushing it, right? Like you have the server fetch, you have to push. I'm not pushing it. I'm not setting up a live WebSocket for these flags to be pushed. It's okay. Like if somebody doesn't get the flag for 30 minutes, that's not the end of the world. So it's a lazy fetch coming from the device. And when the app first launches, it fetches it. When the app logs in, it fetches it. And once in a while, I think 10 or 15 minutes, it does a fetch. So it's a lazy fetch. So it's not very eager. And it's also not a push because, I don't want to have to use WebSocket for that. That gets very expensive very quickly. Not just the amount of money you have to pay to Supabase to use WebSockets. It also, of course, is that WebSockets drains the battery on the mobile devices a lot faster than lazy fetches. If you can configure the lazy fetches to be more sparse and not as frequent, or batch them such that one network call can fetch as many requests as you need. Because in any case, that's optimization talk. So that's I put those things in because if you go back to a couple of updates ago, I had a situation where I was developing another feature, and I was doing both the front end and the back end, and the back end was done. Sorry, the front end was done, and because you can, but the back end wasn't done. The logic was a bit more complicated than I thought, and at that moment I couldn't release any bug fixes or anything in the app because I couldn't turn the front end feature off. In other words, if I distributed the binary, when the user runs it, the app is going to expect the backend services to be available when in fact it wasn't available, and the app would either error out or crash if I didn't catch the exception. So that wasn't a very good developer experience for because I couldn't push out any bug fixes. So that's fixed. Now, the way I did it was very ghetto. I didn't use ConfigCat. ConfigCat is it's a ready-made service that you can just subscribe to. You pay them a little price, and then they give you this configuration management. It is an SDK that you have to integrate with your app, and but they give you a nice dashboard, and then you can configure things in the GUI and stuff like that. It's all very neat. The problem is they do have a free tier, but the free tier limits you to 2 environments, and I have 3 environments. I have integration, staging, and production. And my 3 environment setup is really for the robustness of the app, right? This is a B2B app, and I would want it to be as robust as possible. At least the breakages wouldn't come from my infrastructure, it would come from perhaps upstream or some other parts, dependencies. So I have 3 environments. And if we want to use 3 environments, they start charging you an arm and a leg for that, for configuration management. I guess that makes sense because, you know, if you need 3 environments for most apps, you know, most cottage industry apps don't have 3 environments, and I'm definitely in the minority when it comes to that. So when you get to 3 environments, I think ConfigCat just expects you to be a revenue positive app that's gaining positive momentum, which is not yet the case with me. I need to start marketing. So in any case, that becomes a very expensive alternative. But the thing is, the feature that I really want is very simple. I just need those flags. So you hand roll it, you know, you put it into your, I already have a backend database. I use Supabase, I use Postgres. So I can just put the flag in a table in Supabase and I have this app fetch it. And if you configure the permissions right, you know, it's publicly readable, but it's in its own table with the row level security. So, you know, it's not too big of an issue. That's fine. So that's what I did. I hand rolled a very simple version of configuration management, feature flags, and now the feature flag service is up. I tested it with the new feature that I added. I turned it off. It went off in production. I turned it on. It went on in production. Great. That's it for this week. My goal for next week, this is going to be after July 4th. I'm going to start getting to location, talking to people. That would be interesting. I think I'll have more to talk about next week. I'll see you next week.